So chapter 9, sequences, and we're not doing induction of the binomial theorem. And section 9.2, we're going to talk about arithmetic sequences. So that word looks just like arithmetic, but when we're using it as an adjective to describe the kind of sequence, we pronounce it differently when we say arithmetic. So the first thing we're going to want to do is to determine if a sequence is arithmetic. And then we're going to find a formula for an arithmetic sequence. And then we're going to find the sum of an arithmetic sequence. So remember, the sequence is a list of numbers. It could look like 1, 3, 5, 7, 9, and so on. And we say that can be written as the sequence 2n plus 1. In this case, n would go from 0 and continue on, and that would generate that list of numbers in order. So the first thing we want to look at is an arithmetic sequence. And how we'll know we're arithmetic is the difference between successive terms. So if you take the 3 minus the 1, you get 2. If you take the 5 minus the 3, you get 2. The 7 minus the 5, you get 2, and so on. So successive means the one that comes right after. So an arithmetic sequence can be defined recursively. So I talked a little bit about this last time. You look at a previous term to figure out what the next term has to be. So the first term, a sub 1, we skip putting the subscript on and just call that a, the first term. So in the case of this sequence here, we would say this is a, the first term. Well, then to find the next term, the difference between successive terms is always this number d called the difference. But we can rearrange it using algebra. So do you see if I add a sub n minus 1, then I see I can get the nth term by taking the term before it and adding d. So I can get to this next term by taking 1 and adding 2. I can get to this next term by taking 3 and adding 2. So the difference here, the common difference each time, is 2. So the number a is the first term, and d is called the common difference, because every time I do a difference of two terms that are right next to each other, I get the same number. It's the common number. So we can write the terms of an arithmetic sequence with the first term a sub 1 and a common difference of d using this pattern. So in our case, we would have 1, and then we added d once to get 3. Well, if you start from the first term to get to the third term, you have to add 2 jumps of d to get the 5. And then you have to add 3 jumps of d to get the 7, and so on. So this is the formula, but let's notice something. Let's look at the subscript. N equals 1, 2, 3, 4. So this is a sub 1. This is a sub 1 plus 1d, a sub 1 plus 2d's, a sub 1 plus 3d's. So do you see a pattern here that it's a sub 1 plus n minus 1 times the d, because with the first term we aren't adding a d. So the formula for the nth term is going to be a sub 1 plus n minus 1 d's get added to it. So we're going to look at some sequences, and first we're going to show that the sequence is arithmetic. So what I do is the opposite order of what this problem says, I would write out the first 4 terms. So I would say, let's see, when n equals 1, I'm going to get 4. When n equals 2, I get 7. When n equals 3, I get 10. When n equals 4, I get 13. So this is the sequence that's being generated. So to find the common difference, I do 7 minus 4, 10 minus 7, 13 minus 10, so I can see that my D is 3. So then I look at the first term, it's 4, so it's 4 plus n minus 1 times 3. That's another way of writing this so that I can see that here's the common difference. Here's A, the first term. But can you see how that's really the same formula as this, just written in a different way so that we can see what the D is? Because here's 4 plus 3n minus 3. Okay, so we'll do this one in class. And the second objective is we're going to look for a pattern here to see if we can find a formula for the arithmetic sequence. And I already talked about this a little. So to get each successive term, so that just means the next term, and then the next term, and then the next term, we can see that we're adding D, because that's the difference between the two terms. So to find the nth term, I add n minus 1 copies of D. And this is a formula that will be on the handout that I give you. You don't need to memorize it. Okay, so then we have a theorem for the nth term of an arithmetic sequence. And we actually kind of did the proof already, and then this is the theorem that we proved. For an arithmetic sequence, a sub n, whose first term is a sub 1, and whose common difference is D, the nth term is determined by the formula a sub 1 plus n minus 1 times the D, the common difference. So here's a couple of examples. It says find the nth term of the sequence when the initial term a and the common difference are given. So we just write a sub n equals 6, the first term, plus n minus 1 times, and the common difference can be a negative number. So see how this would say the sequence goes 6, and then you add negative 2 and get 4, and you add negative 2 and get 2, and you add negative 2 and get 0, and so on. So there's no reason it has to be an increasing sequence in this case. In fact, it's a decreasing sequence. So then they want us to find the 51st term. So we're going to use good notation and tell the reader what we're doing. Oh, I'm finding the 51st term. So see where the n is here. Now the n needs to be 51. And I'm going to have 6 plus 50 times negative 2. So that looks like 6 minus 100, or negative 94. So this will be the 51st term, and yay that I don't have to keep going here and going up to 51. I have a formula that will tell me what the 51st term is. So let's do this one together in class. This one's a little trickier where they just give you the pattern, negative 1, 1, 3, and so on. But you can see the first term for sure. That's negative 1, the first one. Well, now we need to find the common difference. So the common difference is 1 minus the term before it, or negative 1. So it looks like it's going to be 2, which has to be the same as the 3 minus the term before it, 2. Okay, so we're good. The D is 2. So my formula for the nth term is a sub 1 plus n minus 1 times D, which is 2. So then if I want the 80th term, have negative 1 plus 80 minus 1 times 2. So negative 1 plus 79 times 2. And that looks like 157. So if I kept writing out the terms until I got to the 80th one, it should be 157. Okay, so this is the more useful kind of examples, and this is the type that will be on the test. So you can look at the handout that I'm going to give you and see that this is the type of problem that I like to put on the test. So we need to find the first term and the common difference. So this is find the a sub 1 and the d, and they're telling us it's arithmetic. So we know a sub n equals a sub 1 plus n minus 1 d. So we're supposed to give the formula for the sequence. So this is the general formula. We need to find the specifics. Well, we know the fourth term is 3. So 1, 2, 3, fourth term is 3. And then the 20th term is 35. So this is n equals 1, 2, 3, 4, and this is the 20th term. So there's lots of different ways to do this. I'm going to show you a very algebraic way because I like that way, but you may be able to come up with other ways of doing it using the pattern and thinking about jumps, that you're jumping up a certain amount to get from 3 to 35 in 16 jumps. So here's the way I like to do it. I say a sub 4, they're telling me, is 3. Well, that's a sub 1 plus 4 minus 1d. So 3 equals a sub 1 plus 3d. So that's one equation, but it has two things I don't know. So then I'm going to use the other piece of information. A sub 20 equals 35. So that's a sub 1 plus 20 minus 1d. So 35 equals a1 plus 19d. Well, now I have a system of equations. 3 equals a1 plus 3d. And 35 equals a1 plus 19d. And good thing in Chapter 8, we just reviewed how to solve systems of equations. So I think I'm going to multiply this upper equation by -1. You can solve it any way you like. And then I'm going to add the two equations and see that 32 equals 16d. So each jump, d must equal 2. So now I know that my formula looks like a sub n equals a sub 1 plus n minus 1 times 2. Now I just need the a sub 1. Well, I have a formula right here that says if I know d, I can find a sub 1. So 3 equals a sub 1 plus 3 times d. So it looks like a sub 1 equals -3. So my formula is -3 plus n minus 1 times 2. So we have found the common difference. D is 2. We found the first term. A sub 1 is -3. And we found the recursive formula for the sequence, which is this formula for the nth term. So we'll do number 38 in class. And I'm going to make a second movie with this sum of the terms.